Hey everybody, welcome back. Had a little bit of time today, so I thought we'd knock out a little machine tool Monday on a Thursday. We have a surface grinder we've had for a long time. I would use it on a rare occasion, but it's kind of been screwed up since I got it. One of the hand wheels was broken, and we never could really use it for any real precise work. It wasn't a machine I needed a ton of the time, but I got it for a really good deal, and because it was damaged and figured one day I'd get to it. So anyway, I now need it for a job, and so we are going to work on the couple things that are screwed up on it. So number one, the hand wheel that's broken. It was broken when I got it and gone. I did locate a new hand wheel from another machine similar to mine that the guy was parting out. Unfortunately, his hand wheel, while both pieces were there, was also broken. So I was able to get that. We need to weld that up so we can put that on the machine. And then our magnetic chuck, which came on the machine and is mounted, has never really worked correctly. It's sort of magnetic, but not real strong. Not sure exactly what's going on with it, but I'm going to go ahead and pull it off the machine, see if we can. I think they come apart from the bottom. The on-off switch has always been really screwy. It's just got like a piece of wire stuck through it. And so anyway, we're going to pull that apart, check that out, and see if we can get those two problems solved on the machine so that we can utilize it for the job we have. Yeah, I did disconnect it. It was wired up for a long time, and I disconnected it when I did some rewiring work on the mill. Once we get these two problems solved, we'll have to rewire it. We've got a wall built now, so I'm going to wire it in, probably tie it into our cold saw. They're both three-phase machines, so I can pick up the wiring where it comes into the cold saw. And I know that's probably not technically correct, but I'm the only one who uses any of these machines, so they're never used more than one at a time. So anyway, that's where we're at. I'm going to jump out in the shop and pull this vise off the machine to get started. Alright, so this is our surface grinder here, and this is our magnetic chuck, which, like I said, you can see this handle's goofy. It's got a piece of wire stuck holding it on, and it just, like, sort of magnets, but it's not real strong, no matter which way. You know, that seems to be off, and then you turn it there, it seems to be on, but it's just not real strong. So I'm just not sure what's going on with it, so we're going to pull it off of here and see what we can figure out. Alright, so I'm going to go ahead and first get this handle off. Alright, looks like that stub is bent. I don't know if that has something to do with it or not, but alright, so from what I can see, this is supposed to slide back and forth, which is what turns it on and off. And this arm is completely okay. So we had a bronze bushing here, and the pivot arm, which is what turned it on and off. The bushing is still pretty tight in here. The arm seems to be screwed up. It's bent, and I think when it's in the bushing, the center of the bushing is all blown out. So that is not going to work very well. And we got to try and figure out a way to slide this magnet on here to see if it's just, once it slides over, that it magnetizes it. I'm going to just grab a little block of wood and see if we can slide it down into the position where it magnetizes. And if that's the case, then we know that we just need to get our pivot arm, which is here, working again to allow this to swivel back and forth like it's supposed to.
That tank, I don't think ever came with a gas cap.
Pretty sure we got a new one.
Okay.
But I don't know where the hell it is. You know.
I remember when I got it, there was no gas
Yeah.
cap, and I had
Well,
to
yeah,
take it
because
off.
they broke it. Yeah. But Nicole probably has it somewhere.
Okay.
All right. So. This is our magnetic part, which we removed from here. And when these align, it should transfer from this into the top plate. And this magnet is super strong here. So that's sliding like it's supposed to. Okay, so here's another problem too. This is the link arm between the magnet, this bushing, which we know is no good, this arm, which I'm pretty sure, well, not I'm pretty sure, I know it's also no good. We're going to have to probably remake this, I think. But this link arm, which ties the two together, it goes in here, and you can see it's just a gigantic sloppy hole. So this fits snug on this side, but it's kind of hard to tell if this is worn out. It doesn't really look worn out. It just looks like it probably never fit, or maybe there's supposed to be a bushing in here as well, and there isn't one. So anyway, that's where we're at. Unfortunately, this is going to end this project until we get some bushings ordered. I think I'm going to measure and see if we can get a bushing that'll fit in here. And this, I think we're going to have to remake, because it has got a shoulder in it and it's bent, which is totally shit. Alright guys, so I'm going to try and find these bushings. One of these days I'll learn how to video record my computer screen so you can see it better, but for now, this is what you get. So we're going to go to McMastercar.com. Actually, it's just McMaster.com. If you're not familiar with this website, definitely check it out. They have all kinds of stuff all over the place, you know, for the types of work we do. Okay, so back to McMaster-Carr. So anyway, they have everything, nuts, bolts, all kinds of bushings. I mean, you can just, you know, a tremendous amount of stuff. So anyway, we're going to start. This is our main bushing, which we can see is chewed up real bad. Yeah, there you go. Alright, so it's kind of a weird dimension. 603 thousandths. This is an old piece, so I wouldn't think it's metric, which would be like 15.3. So let's see if we can find. We want a flange sleeve. We want the length, so we can start by going with the length. Let's see, the length is 471, 1530 seconds. So they do have that. And that gives us a plastic sleeve. So that's not what we want. God, all of this stuff is really bizarre. I mean, it's 10.56 millimeters. Is my thing zeroed? Yeah, it is. 10.6 millimeters. And then in Imperial, it's like 420 thousandths, which is 27/64ths, which is like shy of 7/16. This is really odd dimensionally, which is going to make for not a lot of fun to get this thing fixed. So let's see, this little nub is 5/16, so that's good, and the holes in here are 3/8. So that'll take a regular standard 3/16. They have 1/4 inch, so that's not a big deal. We'll get the 1/4 inch, and the outside diameter will be 376. The hole is 375, so that'll give us a press, and then we can just flatten out the excess length, which is just going to be a little 1/16 of an inch overhang. So McMaster Carr has it here, $1. So real easy. Now, as far as this goes, I'm trying to think of our best way to correct this whole deal. We have this shaft here, which is on an offset of this, so it's like a little cam. This is completely torn to shreds, and ideally, like if we could hold it in the lathe and spin it, we could just take a cut off of here and turn it down to a smaller diameter, which would be fine, still accomplish the same goal, and we could get a bushing with a smaller hole in it and be good there. So that would be one way to do it, but holding this thing in my lathe is going to be very difficult, and there's just nothing to like indicate on or anything because it's all chewed up. I'm thinking if we cut this off, put this in the vise in the mill, we could come in here and touch it with a end mill halfway down through this material. Then I can machine a new pin. We can press that in there and then TIG weld it. I think that's going to probably be the best bet. This is going to suck, I'm not going to lie. But we need our chuck, and I haven't looked, but I imagine a new one is going to be pretty expensive, so fixing this one would really be ideal. And I don't want to put it back together with all this slop in it, because I really think the slop is part of what was making it not function correctly to begin with. So we got our one bushing. Let's try and figure out what kind of bushing we need that'll make this work. So this outside dimension on here is in the body, so that's pretty important. That dimension is, I mean, it's like 15.43 or 607. So let's see if we can find a bushing with a dimension even close to that outside. We could always use a thrust washer if we don't get a flanged bushing, so that would be fine. They have 5/8. I think we're going to end up having to do that. 5/8, and then this might have been a 7/16 hole, but it's so like galled over. Alright, so looks like we're going to have to go for a non-flanged sleeve bearing, and then we'll get a flange washer. So our length, we want it to be a minimum of 3/8, which they probably have. Yep, 3/8 length. There we go. And then we're going to need a thrust washer. So we'll go back to the main page. We'll go to, whoop, that's shims. Go 7/8, and they got a thrust ball bearing. That I kind of like. I think we're going to try that. That should be pretty nice, slick operation. So we're going to try that. And we'll get this stuff ordered up. When it gets here, we will get back to trying to get this thing fixed. All right, guys. Well, that was a rather uneventful, semi-useless project. Well, the project wasn't useless, but the results were less than we would have hoped for. So, anyway, they, we got some parts ordered. We figured out, I think, what the problem was, and hopefully we'll be able to get it solved here in the next, few days or something once we get these parts in. So, anyway, that's it for now. Thank you guys for joining us. Don't forget to subscribe and let us know if you like these kind of off-topic machine tool videos or not in the comments. And we hope to see you next time at Gatti's Garage.